Hi guys, my name's Mr. Lead, and today we're going to be going over the theory of plate tectonics. Now, as a bit of a disclaimer here, the theory of plate tectonics accepts the idea that the Earth is 4.567 billion years old. Now, whether or not you subscribe to that idea, you need to understand that when we talk about plate tectonics, we talk about it with a view that the Earth is really old. There are some aspects of plate tectonics that you can 100% agree on whether or not you believe the Earth is old or not, and there are some aspects that you would only really be able to believe if you also believed that the Earth is old. But nevertheless, and the reason I bring up this disclaimer is because as a Christian myself, I believe that the Earth is created by God. Now, the way that it's created is up to theological debate. You could subscribe to a very literal view of Genesis and believe that the Earth is created in 6 days, or you could say that that's more metaphorical and that in accordance to current day opinions from science, the Earth is a lot older than that. But whether or not you believe in a 6-day creation or an older creation, what you got to understand is that God could have created the world in either way. He has got the power to do that. So there's a much deeper theological debate that can be had about the significance of an Earth that's created in 6 days versus an Earth that's created in longer. But the point I want to get, and the point I want to just make briefly here, is that this shouldn't be a stumbling block of faith. So you shouldn't dismiss theology or dismiss the Bible just because of scientific opinion. You can have a scientific opinion that the Earth is old and still be a Christian. Now, there's a lot more we can delve into in terms of theology, but we're going to delve into the actual topic of plate tectonics. I've never even heard of the idea of plate tectonics. Know that basically, and we're going to unpack this more, basically what it means is that the surface of the Earth, or the crust of the Earth, is actually made up of fragments, these plates, and these plates move over time. This idea was first thought of by a guy named Alfred Wegener. He proposed an idea back in 1950 called continental drift. He suggested that all the continents on Earth would have once existed all together compacted in one supercontinent continent called Pangaea 200 million years ago. And then over time, these continents would have broken apart. It would look a bit like this. All right, so this is what the Earth looks like now. Let me get... Here we go. So this is what the Earth would have at one point supposedly looked like, according to Alfred. And then over time, these continents would have broken apart to be the way that we see the Earth now. So what would make Wegener think of an idea like this? Well, there are two main pieces of evidence. The first is that if you look at the continents on Earth, we've finally come to a point in history where, yes, we got all the continents on Earth mapped out and everyone has this map of the Earth. Alfred looks at this map and thinks, you know what? It kind of looks like a jigsaw puzzle. It kind of looks like South America could fit into Africa here, and Africa could fit in this gap here. It kind of looks like we could piece these continents together a bit. And, you know, it was right. You could probably fit them all together. Now, the second major piece of evidence that Wegener was basing his theory off was fossil evidence. He saw that there were certain fossils that were located in certain locations that didn't really make sense if you just thought that the Earth existed the way it was for however long it did. For example, the MESOSAURUS is a freshwater reptile, and this reptile existed in South Africa and South America. So how on earth could this freshwater reptile exist in both these places while being separated by this giant chasm of saltwater? It didn't make sense. You couldn't get this reptile swimming across to also make a population on this side. And this wasn't just for the MESOSAURUS. There was other examples. I've got to get the pronunciation right. The LYSTROSAURUS was a little reptile that was also found spread across different continents. And again, how would this animal have been able to exist over these different continents? Here's a pretty famous collection of fossil evidence. Here we have the supercontinent known as Gondwana. That's which we see. If we were to piece these continents back together, it would make sense why we're seeing fossil evidence spread across different places. We'd see that at one point these continents were close enough together that you could see populations migrating across different continents. And then over time, they would have been split apart to show us the fossil evidence we have now. But the thing is, Wegner was like, surely guys, this is how it is. But the thing is, Wegner was not able to explain how the continents moved apart. And so because of this, the scientific community thought this was a ridiculous idea. They rejected his idea. And it was forgotten for almost 50 years until around about World War II, or during World War II, there was some new evidence that was coming up that could support Wegner's idea. This was discovered by a man named Harry Hess. Harry Hess was serving in World War II, and he noticed that while out on several ships, he looked in the water and saw that there were these giant chasms in the water. There are these giant rifts, giant chasms that were much deeper than the normal ocean floor. And after World War II, he began to look deeper and deeper into this, and was able to map out an overall chain of chasms known as the Great Global Rift. So this was quite curious. Why is there these cracks here deep in the sea? And if we were to look at it on a more like horizontal view, the average ocean depth is about 4 kilometers deep. But if we see some of these cracks, some of these trenches, the most famous of which is probably the Marianas Trench, this trench is 11 kilometers deep. That's really deep. So there are these trenches all over the world. And as Harry Heston began to look at them, he decided, well, how about we take some samples of the rock around these trenches? Let's take some samples of the ocean floor here, and we'll see whether or not these rocks are from the same age. Now, the scientific community thought if you just measured the age of the rock all across the Earth, it would all be the same, all on the ocean floor. They would all be the same age. But that's actually not what they found. They found that the age of the rocks on the ocean floor was getting older the further away you got from these cracks, which meant that the ocean floor, that these cracks was causing new rock to come out and spread out. So this was ocean spreading. So this meant that, the closer you are to these cracks, the younger you see rock, and the further away you are from the cracks, the older the rock is. And so Harry Hess determined that what we're seeing is new magma rising in these cracks and forming and cooling down to form new rocks. And then as the crack continually gets bigger, more magma rises in its place and forms even younger rock, and of course, this process just keeps going, and we keep seeing new rock being formed. So this meant that suddenly Alfred Wegener's ideas, which were slandered by the scientific community, didn't look very silly anymore. So this suggested that the seafloor was spreading apart, which meant if you were to track back the process of the seafloor spreading apart, you would see a point where all the continents are all in one place, are all together. Harry Hess's official theory was known as seafloor spreading. A bit of terminology here. When we see two land plates being moved apart, this is what creates what's called a rift. And when we see two ocean plates being moved apart, this creates what's called a ridge. Often when we see a rift created, we see a new water come in and a new sea come in to fill its place. That's how the Red Sea has supposedly been created. Now, there is some important evidence that backs up Hess's idea or theory of seafloor spreading. The first is the theory of magnetic striping, or the evidence of magnetic striping. So magnetic striping looks at a special mineral called magnetite. Magnetite is a magnetic mineral, hence the name. Now, magnetite always points north. And so if you were to see magnetite solidifying in some sediments, and you'd cut up that sediment, whatever way you face that rock will always show them, the magnetite will have been frozen in a position where it was originally pointing north. Okay? So what we find with magnetic striping is that you would think that all magnetite you would see on the ocean crust, as long as it's been solidified in the same way, it will always point north. But we don't see that. We see these stripes where we see lots of magnetite pointing north, and then all this magnetite suddenly pointing south. And then later, another stripe pointing north, and another stripe pointing south. And these stripes and this pattern continues all the way across the sea floor. So this suggests that the magnetic, this suggests two things. Firstly, all this magnetite couldn't have settled all at the same time. Otherwise, you would see them all pointing north together. And the second thing this suggests is that the Earth actually reverses its poles sometimes. So say that, for example, this is the Earth, and this is north, this is south. Sometimes the Earth actually swaps its poles. The Earth gets its magnetic field from an iron core, and that iron is molten, and it's always convecting, it's always moving around. After a few million years of moving around, it eventually also turns around the magnetic field, so that north is no longer north. North becomes south, and south becomes north. The Earth doesn't flip around, the magnetic poles just flip. So when the magnetic poles flip, you will now see magnetites all pointing a different way. And so that is what magnetic striping shows. We're seeing these stripes of magnetite pointing one way when north was originally facing this way. Then we see stripes of magnetite pointing this way when north was actually facing that way. So that was the first piece of theory for Hess's seafloor spreading. The second theory is that the age of the seafloor is different all the way across. I mentioned this one earlier. He has tested the ages and carbon dated the ages of different rocks across the Earth. And then the third piece of theory is sediment thickness. You would see, because of Hess's theory of the seafloor spreading, we're seeing the thickness of the sediments are also getting different. The thickness of sediments closer towards the ridge is actually really thin because that's really young rock. But the thickness of sediments that are closer towards the continents where the seafloor has spreaded the furthest and is starting to stack up on each other is much thicker. So therefore, sediment thickness is different there. So that's the introduction to plate tectonics. In the next topic, or in the next lesson, we're going to look more at the different types of plate tectonics and how they all move. Thanks for watching.